In this video, we will discuss the differences between positive rake angle and negative rake angle. So the very first difference for positive rake angle is considered as positive when sum of wedge angle and flank angle is less than 90 degree. So here you can see the wedge angle and flank angle. So this is nothing but the two faces of the cutting tool. This is first face and this is second face. So the angle in between these two faces, that is known as wedge angle, whereas the angle in between this flank and this horizontal line, that is known as flank angle. Okay, so the rake angle is considered as positive when sum of wedge angle and flank angle is less than 90 degree. So here the sum of this wedge angle and the flank angle, it is less than 90 degree. Okay, so when such situation is there, then it is known as positive rake angle. Now the negative rake angle. Rake angle is considered as negative when sum of wedge angle and flank angle is greater than 90 degree. So here you can see an example of negative rake angle. So here you can see this is nothing but the wedge angle and this is the flank angle. Okay, now the sum of this flank angle and the wedge angle, it is greater than 90 degree. Now for this situation, the rake angle is negative rake angle. Okay, so the rake angle is considered as negative when sum of wedge angle and flank angle is greater than 90 degree. Second difference, positive rake offers a thin wedge. Now here you can see this is nothing but the wedge of the cutting tool, okay, or the tip of the cutting tool. Now when the rake angle is positive, in that case this positive rake angle makes this wedge thinner. Okay, so the positive rake offers a thin wedge. As this angle is positive, here you can see this is a positive rake angle, and due to this positive rake angle, the wedge of this cutting tool get thinner. Now for negative negative rake makes wedge thicker. So here this is an example of negative rake angle. Here you can see this is negative rake, and due to this negative rake angle, the wedge of the cutting tool is thick. The wedge of the cutting tool is thick. Third difference, shear deformation of the chip is less because of thin wedge. Now here you can see this is a thin wedge of the cutting tool, and due to this thin wedge, the shear deformation of the chip is less. Okay, now the material in front of the tool tip, this is nothing but the tip of the cutting tool, and the material in front of the tool tip, that's subject to the plastic deformation and it shear off along the face of the cutting tool. Now this cutting tool is pointed, the tip of this cutting tool is very sharp because of this positive rake angle, and that is why shear deformation of the chip is less because of thin wedge. Now the chip or the material in front of this tool tip is subjected to the shear deformation, but as this end is pointed and sharp, so the shear deformation is less. Now negative rake angle, thicker wedge results in high shear deformation of the chip. Now here you can see here the wedge of the cutting tool or the tool tip of the cutting tool is thick, right, and due to which there is high shear deformation. There is high shear deformation of the chip. So here also you can see, now in the first example, here you can see this is nothing but the direction of chip flow. Now this is the direction of the chip flow, whereas in this example, this is the direction of the chip flow. So here you can see the chip is deforming more in case of negative rake angle. Next difference, for positive rake angle, it also tends to reduce the chip thickness and thus CRC remains low. Okay, so due to positive rake angle, this tool tip is very sharp, and due to which the thickness of the chip is less. Okay, whatever chip produced during the machining, the thickness of the chip is less in case of positive rake angle. The next part, that is CRC, that is nothing but chip reduction coefficient. So the chip reduction coefficient is defined as the ratio of chip thickness to uncut chip thickness, and here we are getting the chip with less thickness, and that is why the CRC, that is chip reduction coefficient, that also remains low with positive rake angle. Now the negative rake angle, it tends to increase the chip thickness and thus CRC becomes high. Now here in case of negative rake angle, the chip thickness is high, okay, and as the chip thickness is high, and that is why the CRC will also high in case of negative rake angle. Next difference, cutting force and thus the power consumption during machining is comparatively less for positive rake angle. So this positive rake angle makes the tool tip sharp, okay, and due to which very less force is required to remove the material from the surface of the workpiece, okay, and that is why less cutting force is there and less power consumption, okay. So the cutting force and thus the power consumption during machining is comparatively less with positive rake angle. Now the negative rake angle, under same condition it requires higher cutting force and power. So under same condition means if you are using the same cutting tool material and the same workpiece material, only here in second case we are using negative rake angle. So in that case what happens, this angle will be more, okay, and here there will be more material at the tool tip, right, and that is why this end is not that much sharp, and hence we will require more cutting force and thus the more power to remove the material from the surface of the workpiece with negative rake angle. Next difference, low CRC, low cutting force and low power indicates good machinability, okay, with positive rake angle. So the machinability is nothing but the ability of a material to get machined with a particular cutting tool, okay. So with positive rake angle what happens, this tool tip is very sharp, right, and that is why very less force is required to remove the material, and that is why we will be getting a low CRC, that is chip reduction coefficient, low cutting forces are required, low power is required, and ultimately we can say we will be getting a good machinability with positive rake angle. Now the negative rake angle, machinability is poor with negative rake. So here, with negative rake angle, the tool tip of the material is not that much sharp and hence more forces are required. That means more power is required, right, to remove the material. And against CRC is also high with negative rake angle, right. So machinability is poor for negative rake angle. Next difference, tool tip is less strong and thus prone to catastrophic failure. Now with positive rake angle what happens, this positive rake angle makes this tool tip sharp and there will be very less material at the tool tip, okay, and that is why we cannot use this cutting tool for higher cutting forces or higher feed, because if we increase the feed then there will be more cutting force or more reaction on the tool tip, right, and due to which what happen, this tool tip becomes less strong, okay, as there is very less material at the tool tip, and that is why this tool tip becomes less strong as compared to your negative rake angle. And when the force increase beyond certain limit, so this tool tip may get fell, okay, it may break, right. So the tool tip is less strong and thus prone to catastrophic failure. So suddenly catastrophic failure means a sudden failure. So your tool tip may suddenly fail due to this positive rake angle. Now negative rake angle, tool tip is stronger and thus less chance of sudden breakage. So here also you can see there is more material at the tool tip as compared to your positive rake angle, right, and as there is more material at the tool tip, so this tool can bear more forces, so it makes the tool stronger, right. So the tool tip is stronger and thus less chance of breakage. So as your tool tip is stronger, so there is very less chances of breakage with the negative rake angle. Next difference, higher chip load cannot be applied as the tool cannot withstand it. So as I have already discussed, there is less material at the tool tip, right, and as there is very less material at the tool tip, so you cannot use this cutting tool for higher feed, because if you increase the feed, in that case there will be more cutting forces, right, and more reaction, okay, because your workpiece will also act a force over the tool tip, right, and as there is very less material at the tool tip, so this tool tip may get break, right. So higher chip load cannot be applied as the tool cannot withstand it. Now negative rake angle, higher chip load can be applied safely. Now with negative rake angle, what happens? This there will be more material at the tool tip, and this material makes this cutting tool strong, right? So we can use this cutting tool at higher feed rate. Okay, so higher chip load can be applied safely. Now the last difference. Positive rake is suitable for machining soft and ductile materials such as copper and aluminium. Now, the positive rake angle is used for cutting the ductile material because the ductile material is soft and hence there will be very less force at the tool tip, right? Because with positive rake angle there will be very less material at the tool tip. So this tool is not suitable for machining a hard material, okay, because this can withstand very less forces, right? So it is suitable for cutting a ductile material such as copper, aluminium. Now the negative rake angle. Negative rake is good for machining hard and brittle materials such as titanium, stainless steel. So as I have already discussed, there is very less, there will be large material as compared to positive rake angle at the tool tip, right? So we can use this cutting tool for cutting a hard and brittle material, because for cutting a hard and brittle material more forces are required and we cannot use more forces with positive rake angle, whereas we can use more forces with negative rake angle, right? So such type of cutting tool is used, or the negative rake angle is good for machining hard and brittle materials such as titanium and stainless steel. So thank you so much for watching my video. Thank you.